Hey guys, welcome back to new video, and in this video we're gonna start our journey with RxJava. Now RxJava is not very popular right now because right now Kotlin coroutine is very famous, and when you start your new project in Android development you surely use Kotlin coroutine. But back in the year 2015 or 2014 it is not the case. We have RxJava, and RxJava is a only approach that we can use to do reactive programming. So if you are working at any MNC company or you have any previous project or very old project, surely they were using RxJava because RxJava is very common at that time. And if you want to migrate your RxJava code to Kotlin coroutine or want to work with RxJava, then you should know the basics of RxJava. So let's get started with our video. What is RxJava? Well, RxJava is a very easy way to do reactive programming, and RxJava will only have two things: observable and observer. Observable will eventually act as a publisher which publish data, and observer will observe the data and react it accordingly. So let's start our journey with RxJava. So first thing first, you should go to my GitHub repo, download the initial project and open up into your Android Studio. This will contain all of the basic setup. So basic setup means the dependencies. So when you open the build.gtls file, I have added all the dependencies and I will use this dependency throughout my playlist. So we have here Rx support, as you can see in here. So we have Rx Android, we have RxJava, and also we have Retrofit dependency, room dependency that we'll use later in this playlist. Okay, so open up your main activity and let's start our journey with a very simple example. So as I told you, in RxJava we have two things. We have observable and observer. So I'm going to create a main function in here, and first I want to create a publisher or observable. So I'm going to call this observable. You can create observable using observable dot create, and I'm going to use here create that has a trailing lambda. In this you can pass the type. So I want to emit data which is a type of string, that's why I'm using a string, and in this trailing lambda you are receiving the emitter. So I'm going to rename it from it to emitter, and now it's time to use it. So use emitter dot. As you can see, we are having here a few options. We have on error, we have on next, we have on complete. So on next is used when you want to emit some data from this observable. Then we have on error. So if you encounter any error, you can expose that error or emit that error using on error method. Next we have on complete. So if your observable or your task is complete, you can simply use here on complete and emit the on complete so that your observer will know that your task is complete. Okay, so I want to emit here few information. So I'm using here on next, and I want to emit here string naming first. Similarly, I want to emit one more string naming second. Okay, so we have an observable. Now it's time to observe these changes. So for that we'll create an observer. Use here object observer. Make sure this observer is coming from RxJava 3 core. Type of this thing is a string because as you can see our observable emit string, that's why. Open a pair of parentheses, and in this we have few functions. So simply override it. Press Ctrl I and enter. So we have here on subscribe, on next, on error and on complete. So if you want to observe the changes of your observable, on that case you have to subscribe your observer to this observable, then only you are able to observe the changes. So for that, at the bottom I'm using here observable, and in this we have a method naming subscribe, and in this subscribe you can pass your observer, and that's it. So when you emit here using on next any values, it will trigger on next. So I'm gonna use here print ln and print the value. If we encounter any error, again I'm gonna use here print ln, and I'm gonna use here message error, and after that the actual message which is e. And when our emitter will trigger on complete method, then we'll receive this event. So I'm gonna use here print ln, and I'm gonna print complete. Similarly on subscribe, I'm gonna use print ln and use here subscribe. Alright, so now I'm going to execute my main function. As you can see, so when we attach this observer to this observable, subscribe block will trigger. So we have subscribe, and after that we'll emitting here first and second. So it will eventually trigger this on next, and on next will print the first value and this second value. Now what will happen if I encounter any error? So emitter dot on error, and let's say I want to pass here throwable that has this is error message. Okay, so now when I execute it, as you can see, we have subscribe, we have first, second, and lastly the error. Now I want to emit one more value, which is 3, and execute it. We are not getting 3 because before that we are receiving the error message. Okay, now just for time being, remove this error, and lastly I'm gonna use here on complete. And when you execute it, as you can see, we have first received the subscribe event, then first, second, third, and lastly on complete. Okay, so by using this you can actually emit values from your observable and observe the changes using your observer. Now what will happen if I just uncomment this error and execute it? Because we are receiving the error, on next 3 and on complete will never trigger. Now is there any way to resume our emission from here when we receive any kind of error? Yes, it is possible, and we can do this thing by using on error resume next. So if you want to use any kind of backup observable when we encounter any error, then you can use on error resume next. So for that, because I want a backup observable in here, I'm going to create here a backup observable. So observable, just I'm gonna say this error. So this is my backup observable, so I'm gonna use this backup observable. So what will happen when we receive an error, it will call this block. Because this block has an backup observable, will emit these values, and after that it will continue their emission. So when you execute it, now this time we are not receiving this message, this is error message, because when we encounter this error it will eventually come to this block, and this block has a backup observable. So backup observable has an observable that emit error, and this is something which is receiving in here. So error, and after that we'll receive the complete. But here you can notice we are not receiving this 3, because when you encounter on error, it will start using the backup observable, and after that it will trigger only the on complete. It will never emit the values that we are having within this on error and on complete. So let me show you by using emitter on next, and this time I want to, let's say, emit 5. So when you execute it, you are not going to see these two emissions. So we are emitting first, second, and when we encounter the error, it comes in here, it uses the backup observable, and after that it will complete our emission. So on error resume next is used when you want to continue your emissions during an error. So we saw how to use on error resume next. Now we have few more operators, do on each. So this will trigger every time when you emit any new values. So I'm using here print ln, and I'm going to call this on each, and just after that I'm showing the value. So it dot value, and when you execute it, so subscribe on each first, and after that we'll receive this first in our on next observer. Then we have on each second, we'll receive this second, on each null, because we are getting the error, that's why we are getting here null value. Similarly, we have do on error. So if you want to do something when you receive error, you can do that thing within this lambda. We have do finally. So if you want to execute some task at the end of your emissions, you can do that thing very easily by using do finally. So I'm using here print ln and call this finally. So when you execute it, as you can see, this finally block will trigger no matter whether you are receiving an error or anything else. It will surely trigger do finally. It's like try catch finally. Just we have in our kotlin try catch finally. So if you want to execute something at the end of your try catch, you can use finally, and finally block must trigger every time. It doesn't matter whether you are catching any error or not, it will surely trigger the finally block. Similarly, it goes in here. Talk about subject family of our RxJava. So subject family will act as both observable and observer at the same time. We have 4 different types of subject in RxJava. We use publish subject, behavior subject, replay subject, and async subject, and we'll discuss one by one. So let's begin our journey with publish subject. So function main, and in this I'm gonna create my publish subject. So it's very easy. You can simply use here publish subject dot create, and I want to emit here string values. That's why I'm gonna give the type string. As I told you, it acts as both observable and observer. So property of observable is to emit values. So we'll use on next to emit values. So subject on next, and I'm gonna emit here first, and subject on next, I'm gonna emit the second. So we are emitting 2 values. Now we're gonna observe these changes on the subject. So to do that, you can simply use subject, and we are not going to create any explicit observer for this. We have a function naming subscribe, and in its trailing lambda we are getting the values one by one. So I'm using here print ln and print the values. Now when I execute this main function, as you can see, we are getting first and second. So we have a problem in here, and it says the result of subscribe is not used, and if you check the type is disposable. So disposable is eventually used to dispose your subscription when you are done using of it. So for this we have composite disposable naming variable, and this is a object of our composite disposable. Now we are getting a disposable from this subject.subscribe function. So I'm gonna store this thing in dispose, and after that I'm using composite disposable and add this disposable into my composite disposable. And at the end of our function, we're gonna simply remove this subscription from our memory. So to do that, you can simply use composite disposable and call dispose. That's it. This will remove this subscription from our memory. By doing this, it will also optimize your memory. Now when you re-execute it, nothing change, everything will be fine, first and second. Now what will happen if I attach one more subscribe to my subject after this emission? So subject dot subscribe, and I don't want to attach this thing my disposable for a time being. Just to show you, I'm using here print ln and print the values, but before that I'm gonna add a prefix naming second. Okay, so when I execute it, so first second, this is coming from our top subscription, but from the bottom we are not getting anything. This is because when you emit something in your publish subject, it will eventually give you the emission in your first subscription. So because we have already subscribed this block to this subject, that's why we are getting this information in here. And after this emission we are subscribing this subscription, that's why we are not getting this emission in this block. So that's it for our publish subject. Now we're gonna see behavior subject. So for that, just change this thing from publish subject to behavior subject, and I'm gonna use here different function which is create default, and default value is empty. Cool. So rest of things are pretty much same. So we are attaching a subscription here. We are emitting 2 values, and at the end we are attaching one more subscription. Now when I execute it, you see difference. So you can see in the first subscription we are getting the first and second, and in the last subscription we are getting the second, or you can see the latest last emission. So what does it mean? It means that your behavior subject will eventually cache the last emission, and when you attach new subscription to your subject, it will give you the last emission which is cached. So this is a difference between behavior subject and publish subject. Now we have one more subject which is async subject, and I'm using here create operator to create it. Type of this thing is string. So now when you execute it, okay, so you are not getting anything. This is because when you are using async subject, until and unless you are not calling subject.onComplete, it will never emit anything to your subscription. So at the end, I'm gonna use my subject and call onComplete. And now when I execute it, you can see we are getting the values. So from the first subscription we are getting the second, and from the last subscription we are getting the second. So it will only give you the latest emission. It will never give us the first emission because it is designed to give you the last emission. That's why we are receiving here second and second. So it doesn't matter if you create, let's say, one more subscription. So we have subscribe and use here println, and this time I'm gonna call this third and use it. So it will give you third second, as you can see in here. So it will also cache the last information or the last emission and return you only the latest or the last emission. And if you create any new subscription, eventually it will give you the last emission. Cool. So we are done with our async subject, and also we'll discuss the differences between publish subject, behavior subject, and async subject. Now it's time to see the replay subject. So we have here replay subject, and I'm gonna remove this subscription, I mean the third subscription. So rest of thing is pretty much same. Now when I execute it, as you can see, we are getting the first second, and if you attach any new subscription, automatically it will provide you all the previous emissions too. It is not like that it will give you the latest emission, it will give you or provide you the all the emission. That means it caches the information. When I remove this subject.onComplete, still it works because it is not async subject, as you can see in here. So these are the different subject family that we have discussed, and also we discussed the differences between them. Now we are going to use the publish subject in our composable to see how we can use it in our composables. So for that, I'm going to create a composable and call this counter. So basically we are going to create a counter app. So first we require an state naming counter. I'm using here a remember savable mutable state of 0. Import it. Okay, so we have counter, and corresponding to that we have subject. Remember, so we're gonna use here publish subject create, and this time I'm gonna use here type unit because we just want to emit an event. So we have subject, we have counter, and next we have disposable. Remember composite disposable. Now I'm going to create a column, and in this column I'm using my modifier fill max size. Its vertical arrangement is on the center, and its horizontal alignment is also on the center. Now in this column I'm having a text which is eventually used to show us the counter. Just below to it we have a spacer height of 12 dp. Import this dp, and just below to it we have a button. So on click we'll just going to write the logic. In the UI I'm having a text which says increase. Now we are going to write a logic for incrementing our counter. So for that we're gonna use our subject and just emit an event. Because type is unit, that's why I'm using here unit. So what it will do, it will simply emit an event to our subject. I'm using a launch effect and execute this block, and also I'm using a disposable effect. Key is unit, and we have on dispose. So when our composable dispose from the screen, we'll use subject, sorry, not subject, we use dispose, disposable, and dispose all of the things that we have present in this disposable. So we have a variable, and the variable name is dispose. We use subject and simply do subscribe on it. So when user click on this button, we're gonna emit an event. So this event will be coming in our subscribe, and in this subscribe I'm gonna use my counter and increment our counter, right? So we have a disposable, and this disposable is simply used to dispose our subscription at the end of our screen. So we have a very simple counter composable. In this counter composable we have state, we have publish subject, and we have disposable. in the launch effect we are attaching, or you can say subscribe to our subject, and when we receive any event we wanna increment our counter, and at the end we'll simply take this disposable in a dispose variable, and at the end we'll adding this dispose into our disposable, and in the disposable effect we gonna dispose it everything once our composable is not visible to the screen, and this is our column. So now I'm gonna use this counter in here, and in this counter we have modifier padding is coming from inner padding, fill max size. So in our column we are using the small modifier, which is cool. Now instead of running this thing in our emulator, I'm using here preview. Okay, so this is our counter and I want to use this thing in interactive mode. So when you click on this increase, as you can see, it will increase our counter state. So by using this you can actually use your publish subject. Similarly you can use behavior subject, async subject and replace subject based on your use cases. So we'll talk about backpressure strategy in RxJava. So let's say your publisher can publish data way faster than your consumer can consume it. In this case, there might be a chance of out of memory exception arises. When RxJava was introduced back in 2014 or 15, memory is very limited. So these are the most important thing that you should know. But right now we have a 8 GB or sometimes 12 GB RAM of mobile devices. This might not happen, but still you have to know the basics. So let's see how we can handle this situation, backpressure strategy. So for that we have a main function, and in this main function we have an observable. Type of this thing is int. We have an emitter in it, and I want to create a loop. Start from 1 and goes up to 100,000 times. Emitter on next, just emit the values one by one, and when we are done with the loop we'll use our emitter and use on complete. Just below to it I'm having my observable. Simply subscribe on this observable because our consumer can consume data slowly. So just use here thread.sleep and produce delay of 100 millisecond and print the values. So right now we are using observable. So when you execute it, so here you can see we are getting 1 2 3 4 5 6 and it goes up to 100,000 times. But what will happen if our memory is very limited? Let's say this 100,000 times is not possible with 2 KB RAM. Now in this case you have to handle your backpressure strategy, otherwise it will throw an exception of out of memory. So let's see how we can fix this issue. To fix this issue we'll use Flowable and put this lambda within a small circular bracket. Now the second parameter of our flowable.create function will have a backpressure strategy, and just type backpressure and you will get all of the different types of handling the backpressure. So we'll use buffer. What buffer will do? It will cache all of the emissions. So let's use buffer and execute it. You will see emission from 1 to 100,000, no difference. But make sure when you are using buffer, as I told you, buffer will cache all of the emission. If your memory is small and still you want to cache all of the emissions, it will throw an exception of out of memory. So be aware when you are using backpressure strategy.buffer. Now with drop it is not the case. It will simply drop the older values. Execute it and it will never crash because it simply dropped the older values. And because it is dropping few values, data loss possible. Okay, so this is our drop. And lastly we have latest. So it drops the older values and only care about the latest value. When you execute it, there will be no difference in the emissions. You will see everything from 1 to 100,000 because we have a lot of memory in our console or host. Okay, so we have 3 main types of backpressure handling strategy in RxJava, and we saw each of them: drop, latest and buffer. And also I have told you the differences between them and what are the use cases. Depending on the use case, you can use any of your backpressure strategy in your application. So observable is usually used with a normal UI events, but flowable is used when your publisher emission speed is unpredictable. Then we'll use Flowable, because Flowable also contain the backpressure handling strategy. We're gonna talk about transforming operators in RxJava that we have. So we're gonna discuss here map, flat map, concat map, and switch map. So let's begin our journey with map. So first we have here map transformation. So I'm having here an observable. We have few items in it like 1, 2, 3, 4, 5. So map transformation is used when you want to perform transformation on each emissions. Like here in this observable we are having 1, 2, 3, 4, 5. Now these items are representing the emissions. So if you will use here subscribe and print ln, print the values, and when you execute it you will get all of the items 1, 2, 3, 4, 5. Now I want to perform transformation on each item, or you can say on each emissions. So to do that we'll use here map. So let's say I want to multiply all of my emissions with 2. So use here it into 2. It represent the emissions or emitted value, and 2 will eventually use to modify this value, and after that we'll subscribe, or you can say consume the transformed value, execute it. So here you can see we are getting 2, 4, 6, 8, 10. So eventually it is transformed. So this is what map transform is. You can use map transformation when you want to perform transformation on each emissions or on each items. Next we have flat map. So in order to explain this flat map you properly, I'm gonna create a function get user details and pass the user ID. Type of this thing is integer, and it will return me an observable of type string. So we have here delay time. Basically this function will mimic the network request call. From 100 to 500 will take any random and convert it into long. Return observable just, and as you can see the return type of this thing is observable, type is string. So user is, and use the user ID. I want to introduce delay just to mimic the network request call. Introduce our delay time, and in place of the time unit I'm using here milliseconds. So that's it. This get user detail will eventually provide me the user detail, and also it mimics the network request call because of this delay. Sorry, I'm using here debounce, which is wrong. We have to use here delay. Cool. So just below to our flat map comment I'm gonna create a flat map observable just, and in this we have 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5 will eventually represent a user ID. Use here subscribe and print the values one by one. And just before our flat map I'm gonna use here print ln just to make a differentiator between our map and flat map. Execute it. 1, 2, 3, 4, 5, which is correct. Okay, so now I want to use flat map. What flat map will do? Flat map is used when you want to convert or transform an observable into a new observable, and in flat map order doesn't matter. If you want to execute any task in which order or sequence doesn't matter, you can go with flat map. So we'll use here flat map. It will give us the user ID one by one, and we have a function naming get user detail which will mimic the network request call, and in this I'm gonna pass my user ID. But if you are using here subscribe you will get nothing, as you can see in here, because our task is not completed yet. So instead of using subscribe, use here blocking subscribe and execute it. As you can see, we are retrieving the information about the user ID for first. As I said to you, in flat map order doesn't matter. If you want to execute your task in sequence, flat map is not for you. If you want to execute your task without taking care of the sequence, then you can use flat map, of course. So here you can see we are retrieving the information about the user ID for first, then 5, then 2, then 1, then 3, right? So with flat map, this is the not the issue, this is the functionality of flat map. It doesn't care about the sequence. Now what will happen if I just change this flat map to concat map? In flat map, order doesn't matter. In concat map, order matters. So re-execute it. 1 2 3 4 5. As I said to you, in concat map, order matters. So now we are going to discuss switch map transforming operator. So for that, first we're gonna create a publish subject, because publish subject is required in order to show you the use case of switch map. So switch map is used when you want to drop the previous emission when new emission arrive. So subject, we have switch map on it, and we are retrieving or receiving the query in a form of emission from this publish subject. So when we get any query, we'll use here observable dot just, and we're gonna type the query, mention the incoming query, and at the end just add the results. And we have a delay. Just to show you how switch map will work, I'm gonna attach a delay. So this delay will eventually mimic the network request call. So 500 time unit is in millis. We'll use subscribe print ln just to print the values. So in this subject I have attached switch map transformation, and after that I will subscribe on it just to consume the incoming values. Now it's time to push some emissions in this subject. So subject on next, I'm gonna use here jet. So user type in query jet. Subject on next jetpack. Okay. Subject dot on next jetpack compose. And just after that, because our network request will take 500 millisecond, I'm gonna sleep my thread for 3 seconds in order to complete this emission, right? So due to this reason, I'm using here thread sleep 3 seconds. Now when I execute it, so logically it will give you this emission. As you can see in here, query jetpack compose results. This is happening because switch map will drop the previous emission and it will only take care about the new emissions that arrives. I'm gonna show you how you can use filter operators in your RxJava streams. So first we have main function, and in this main we have an observable. Make sure this observable is coming from RxJava 3.core, and in this we have j, then we have jetpack, and we have android item, and then we have android kotlin, and my name which is Himanshu, and I'm gonna add one duplicate value jetpack. So now we have observable. It's time to see how we can use filter operator. So observable, we have first filter operator naming filter, and I want to filter all of the value which has length less than 4. So it dot length is greater than 4, then only emit those values. I'm using here print ln and print the values one by one. Execute it. You can see we are getting jetpack, android, kotlin, Himanshu, jetpack. So basically all of the items that we are seeing right now in our console has length greater than 4, and we have jetpack 2 times. So basically we have duplicate value, and I want to remove this duplicate value. So if you want to remove it, you can use distinct operator. Re-execute it, you won't see jetpack 2 times. Jetpack, android, kotlin, Himanshu. Now let's say I want to take only the first emission. So for that we have a function naming take, and in this take you can pass the numbers of emission that you want to take. So we are interested only in the first emission. Execute it and you will see only the first emission, which is jetpack. Similarly, if you want to take the last emission, you can use take last, or you can also pass here 3, 4, whatever emission you want from last. So let's say I'm using the last 3 emissions, and I'm getting last 3 emission, which is if you see the observable kotlin, Himanshu, jetpack. So we have android kotlin, Himanshu because it removes this duplicate value jetpack. and once you remove the Jetpack duplicate values, we have Android, Kotlin, Himanshu. That is what we are getting in here. Similarly, if we have take, we have skip. So if you want to skip emissions, you can do that thing very easily by using a skip function. Execute it and it will skip the first 3 emissions, and now we have only Himanshu. Similarly, if you want to skip the last emission, I'm using here 1, execute it, it will skip the last emission. Cool. So now we're gonna see take until, take while, skip until. These are the some advanced operators, filter operators basically. So to show you that, let me remove all of the operators that we have, and first we'll see take while. So in this training lambda, you can pass your condition, and if your condition is true, then only it will emit those values. So if it dot length is less than 4, so for j and jet it is true. That means we are only getting these 2 values in my final result. Jet, because length of j is 1, which is true, length of jet is 3, which is also true, and after that we have 7, and 7 is greater than 4, which is wrong. And Android, Kotlin, Himanshu, Jetpack is also not satisfying this condition. So that's why I'm getting here j and jet. Now what will happen if I revert this condition and execute it? Well, we can't see any emissions because j has length 1 and 1 is not greater than 4. So if your first condition is false, it doesn't matter what are your next emission will have, it still won't emit those values. If first condition is false, it won't emit the other values. This is the use case of take while. So we are done with take while. Take while is used when you want to emit values based on a certain condition. Now we're gonna see take until. So take until, it's the reverse of take while. If this condition is true, it stops the emissions. So if length is greater than 4, if this condition is true, it will simply stop the emission. Execute it, you will see j, jet and Jetpack. Why Jetpack? Because Jetpack has length 7 and 7 is greater than true. If our condition is true, it simply stops. But in our third emission, we have Jetpack that has length 7, and this condition will act as a threshold. This will give you true, and after that it won't emit any value. So it will emit the last value on which this predicate will return you true. In our case, Jetpack is 7 and 7 is greater than 4, which is true. Because Jetpack is providing the true value, and due to that reason it will emit this value, and after that it won't emit any value. This is also a property of take until. It will emit the value which will give us true in their predicate. So we have done with take until and take while, and now we are going to discuss skip while and skip until. So let's begin with our skip while. So if this condition is true that you are going to mention in your training lambda, then it will skip those emission, otherwise it won't. So if my it dot length is less than 4, I'm gonna skip those emissions. So in this subscribe, I'm using here println and print the values. So logically it skips j and jet. Execute it, and we are getting Jetpack, Android, Kotlin, Himanshu, but we won't receive j and jet because of this condition. This condition is true for these two. Now what will happen if I just revert the condition and execute it? And this time we are getting all the emissions that we are having in our observable. This is because our first condition, basically the first emission value, will have value j and its length is 1, and 1 is not greater than 4. That means our predicate is false, and once it falls, it won't care about the other emission. It simply start emitting all of the values that we are receiving from this observable, and due to that reason, because our first condition for j is false, it won't care about the other emission. It will simply emit directly without checking any kind of condition in our skip while. That's why we are receiving j, jet, Jetpack, Android, Kotlin, Himanshu and Jetpack. So we are done with our skip while. Now it's time to see skip until. So in skip until we have to pass our observable, and once the observable which you have mentioned in your skip until start emitting values, then only we will getting all of the emitted value in our subscriber or the consumer. So for that I'm gonna create a variable naming timer observable. This is nothing but an observable. We have timer delay of 1 second, so time unit is seconds. You can mention your timer observable in here. So once your timer observable start emitting values, then only will receive those events in our subscription. At the end I'm using here thread.sleep, and I want to sleep my thread for 4 seconds in order to complete this execution. Execute it for after 4 seconds our process get completed, and we are not seeing anything in here. This is because it will take 1 second to complete, and before that all of the emissions have been emitted from this observable. So what I'm going to do in here, I'm going to attach delay to my observable, and this time I'm using 2 seconds delay, and time unit is nothing but seconds, and this time you will receive everything. So 213, so total time taken by this observable is 3, and we are sleeping our thread for 4 seconds. That means our program will be executed properly. And now when you execute it, you can see we are getting all the things, because after 1 second this observable start emitting values, and once it start emitting values, we are getting all of the emissions from this observable in this subscription. So this is the use case of skip until. When you are having any other observable and you want to start your subscription when your second observable start observing data. Now we're gonna talk about debounce. Debounce is actually used to provide throttle, and usually debounce is used in search bar. So user when type something, instead of calling our API directly, will wait for some time, and if user wait let's say for 1 second, then only will hit our backend API. So in this case we'll use debounce. So for that I'm gonna create an observable, create, type of this thing is string, and we have emitter. So first I'm gonna use emitter and emit values, let's say j, then I'm gonna sleep my thread for 100 milliseconds. Then we have emitter dot on it, basically we emit jetpack, and we'll use thread dot sleep for let's say 300 milliseconds. We'll use emitter and again emit value. So emit values will eventually use to mimic the user input. So first user type j, and then it wait for 100 milliseconds, and after that it type jetpack, wait for 300 milliseconds, and after that it types android course, and it wait for let's say 1 second. Now just below to it I'm using observable, and we have debounce, and I want to produce throttle of 500 millisecond. Time unit is in millisecond. At the end I'm gonna use subscribe and print the value. So logically we'll receive android course, because after typing android course user will wait 1000 millisecond, and 1000 millisecond is greater than 500 millisecond. So logically we'll receive android course. Execute it, you'll see we are getting android course. We're gonna discuss few operators using which you can merge more than one observable together in RxJava. So in RxJava we have mostly 3 operators. We have merge, zip and concat. So let's begin our journey with merge. So for that I'm gonna create our main function, and in this main function we have 2 observables. So this is my first observable, and make sure this observable is coming from your RxJava 3.core package. We have interval, and after 300 millisecond I want to emit values. I want to perform some transformation. Due to that reason I'm using here map. We'll simply use here observable 1 and its value, and I want to take only the first 5 emission. Similarly, let me make some space for you. Similarly we have one more observable, observable 2. Observable interval, this time I'm using here 500 millisecond. Time unit is in millisecond. I'm using here map in order to perform transformation. So observable 2, and at the end use here its value. And lastly we are only interested in the first 5 emission, that's why I'm using here take 5. Okay, so now it's time to use merge. So observable dot merge, and in this merge you can pass your observable 1 and observable 2, and simply use here blocking subscribe because we are dealing with time. This is the reason why I'm using here blocking subscribe. Use here print ln and print your emissions. Execute it and you will see all of the values. So you can notice in here, first we'll get observable 1, then observable 2, then observable 1, again we get observable 1 emissions. This is because when you are using merge, in merge order doesn't matter. Sometime it take observable 1 and sometime it will emit values from observable 2. So if you want to merge more than one observable and for you order doesn't matter, you can go with merge. Now we're going to discuss zip. So for zip, just remove the previous collection. Use here observable.zip, observable 1, observable 2, open a pair of parentheses, and in this pair of parentheses you will receive your values. First we have observable 1, then we have observable 2. So this observable when emit something, this value will represent by observe 1, and observable 2 emit something, this value represent by observe 2. Now in this lambda you can perform transformation if you want to. So I want to perform here some transformation. So first I want to use my observable 1 emission, use dash, and after we'll use observable 2. And at the end I'm using here blocking subscribe, use here print ln and print its value. So it will eventually print the emissions. Okay, so in this case you will notice all of your execution is happening in pairwise. So observable 1 and observable 2 will execute together. But in zip there are few problems, and the problem is let's say your observable time interval is 10 seconds. So if you are using zip, so zip will first execute, emit the values from observable 2 because it has only 500 time in millis, but for the first observable you have 10 seconds. So it will wait for 10 seconds, and once it receives the value from observable 1, then only will consume those emissions in our blocking subscribe. So if you want to merge your observable in pairwise, then you can use zip. As you can see in here, first we have observable 1, then it waits for observable 2, and once it emits the first emission, then only will receive this value. So this is a major difference between merge and zip. Zip will execute your observable or consume your observable pairwise, but in merge it is not the case. Now we're going to discuss concat. In concat, sequence matter. So just remove all of this thing, create an observable 1. So we have observable 1, and in this we'll have few items. Let's say we have A, we have B, and lastly we have C. And I want to introduce delay just to show you the concept. So let's say I'm using a 500, time unit is in millis. So this is my first observable, then we have observable 2. So observable just, and in this we have number 1 2 3, let's say we have 3. So now use observable dot concat. Now in concat, sequence matter. So if I'm using here observable 1 and then observable 2 and use blocking subscribe, print the consumed values one by one. So first it will execute your observable 1. Basically once our observable 1 start emitting value, then only we'll get this ABC because we have delay of 500 milliseconds, and after that it will execute our observable 2. Now we have a problem in here, not a problem, but there might be a situation where you will get this problem. And the problem is, let's say instead of using here 500 milliseconds, let's say I'm using here 15 seconds. So now when you execute it, it will wait for 15 seconds because in concat sequence matter. So first it will execute observable 1 and then only it will go for observable 2. So it will wait 15 seconds, and once this emission is complete, then we'll use observable 2, and when it's emit value, we'll simply print those. So as you can see, it will wait for 15 seconds, and after that we'll receive these 3 emissions, and once we receive these 3 emissions, this execution is completed, and after that it will start collecting the observable two emissions 1 to 3. So these three operators you can use to merge more than one observable. We're gonna create a mail search app using RxJava. We will try to learn about scheduler, which is the most important thing if you want to do asynchronous programming with RxJava. Open your Gradle script, build.gradle.kit of module app level. So we have dependencies over here. First we have retrofit dependency. Retrofit is a third party library using which we can perform backend communication. Then we have two dependency. This dependency is actually used to initialize our view model in composables. Then we have serialization dependency, lifecycle dependency. This lifecycle dependency is actually used to provide view model lifecycle. And lastly, we have coil image loading library. So using URL, you can download image with this library. Scroll up, we have few plugins like serialization plugin, Kotlin parcelize, and KAPT, Kotlin annotation processor. In build.gradle.kts, it is pretty much same. When you create a new project, you will get all these plugins by default. Just close it, and now it's time to show you the API that I'm gonna consume in this video. So let me just drag this thing from my second screen. So this is the website, the MailDB. This will provide us few free REST APIs, and this is the API that I'm gonna consume for searching. So this is our JSON response. I'm gonna first copy this response, and corresponding to this JSON object, I'm gonna create my model classes. Just drag this thing to my second screen, and now it's time to open up our package structure. And in this video, we're gonna use MVVM architecture, model, view, view model. So responsibility of model is to get data either from local or remote data source. Once it get data, do some processing, it will give this information to our view model, and view model contains all of our business logic. Once our business logic is applied, it will expose this information to our view, and view is actually used to show you the user interface. It's very easy. So first let's begin our package structure. First we have model package, then we have view model package, and lastly we have our view. Because this UI and this main activity is a view, that's why I'm gonna put these two things in my view package. Okay, so now it's time to begin with our model, and in this model I'm gonna create a package and call this DTOs. So DTOs is nothing but a model classes which is actually used to transfer data from your backend to frontend, or from your backend to your mobile device. So right click, new. This is a plugin that I'm gonna use here, Kotlin data class file from JSON. You can get this plugin very easily by going to this file, go to this Android Studio. In the settings we have plugin, and in this plugin you can simply type here Kotlin JSON to Kotlin class. So you can simply install this plugin and restart your Android Studio, and after that when you right click on it, go to new, you will have this plugin over here. Click on it, just paste your JSON response, and I'm gonna call this mail response. Just press enter. So we have here our mail response, and this mail response contain mails, which is a list of mail, and this is our mail which contain all of the information regarding our mail. I'm gonna rename this thing from mail to mail DTO because it actually represents a data transfer object, that's why. Okay, so I'm gonna remove few parameters from this because we don't use in our user interface. So first I'm gonna remove all of these two. Okay, so measurement is also we're gonna remove because we don't want to use it. str source will never use it, so remove it. Date modified is also will not use it. Mail ID is fine, string area is fine, category is fine. This also will not use. Instruction, mail, mail thumbnail, tags, str YouTube. Okay, so this looks cool to me. Alright, so this is our model. Once we receive the JSON response, we do some serialization, and after that we'll map this JSON response with our mail response. Okay, and this will be done by our retrofit. So let's create our retrofit instance. So in this model I'm gonna create an object and call this a retrofit instance. In this we have a function naming get instance, and it will return a retrofit instance. So let's build it. Retrofit builder, we have to mention our base URL. So let me copy this API for you and paste in here just to make a reference very easy. So this is our base URL. Next we have to add converter factory. This converter factory is actually used to convert your JSON response into model classes, and we'll use here JSON converter factory dot create. Next we have to attach a add call adapter factory. If you want to use the response in a form of observable or in a form of Rx way, then you should add this add call adapter factory, and in this we have to pass RxJava 3 call adapter factory dot create, and that's it. Lastly, you can build it and return it. So now we do have a retrofit instance. It's time to create our API service interface, and that API service interface implementation will be returning by our retrofit. So let's see how we can create API service. So for that, just create an interface naming API service. Go to the retrofit instance and copy this URL or endpoint, come back to your API service and just paste it in order to take reference. So we have get function, and I'm gonna call this function is search, and simply pass your query. In this get we're gonna mention our path. So path is starting from API and goes up to search PHP. So just use it, and next we have to mention our query. So query is nothing but represented in a form of S, and it will return me an observable of type mail response. Okay, so now it's time to provide the implementation for this API service. So for that, go to your retrofit instance and create one more function, and this function is actually used to provide the implementation for API service. So I'm going to call this provide API service, pass retrofit, and this will return you API service. So instead of passing this retrofit, I'm going to use get instance function. We'll have a function naming create in it and simply mention your API service. This will return you implementation. Remove it. No need of passing retrofit as a parameter to this provide service. Okay, so now I'm gonna make this function private. We have an implementation for my API service. So we are pretty much done with our API service. Now it's time to create a repository, because we're gonna use here a repository pattern. So in this model, I'm gonna create a class, and the class name is mail repository. And in this class, we're gonna create an instance of our API service. So private while API service, type of this thing is API service, and I'm using here lazy. Use retrofit instance dot provide API service. So this will provide you API service. Now we have a function naming search, pass your query, and use your API service dot search, simply mention your query. So we are done with our model. Now it's time to continue with our view model. So in this view model package, I'm gonna create a mail view model naming view model. Make sure to extend this class with view model, and within this we're gonna create our repository. Type is mail repository, and initialize lazily by using our mail repository object. So first we're gonna create a data class which is actually used to hold our UI state. So at the bottom of this class, I'm gonna create a data class, and the data class name is UI state. We have here is loading naming boolean, initial value is false, then we have error, type of this thing is string, and initialize this thing with empty string, and lastly we have results. This represent list of mail detail, and initial value is null. Now I'm gonna create a mutable state flow naming a UI state, mutable state flow, and initial value is UI state. Just below to it, we're gonna create one more UI state which is actually used to expose this mutable state flow in a form of state flow. Okay, so now we're gonna create one query naming variable which actually holds the query which user enters in our text field or search bar. So for that we'll use publish subject. If you don't know about publish subject, you can go and watch my RxJava playlist. So we'll have here query which is actually publish subject. So publish subject dot create, type of this thing is string. Just below to it we have a function naming update query, and the sole purpose of this function is to update our publish subject query. So if user send any query from this function, we're gonna use query on next and pass this query. Okay, so now in the init block I'm gonna use this query, and in this query first I'm gonna check it is not empty. After that we'll produce some throttle using debounce. 500 time unit is in milliseconds. After that we'll use here distinct until change. I mean, if our query won't change, then no need to emit the values, simply just cancel it. Then we have switch map function, and this will give you a new query. Now we have the query which user has entered in the search field. It's time to fetch this information. Now here we'll use schedulers. Now what is schedulers? So before understanding about the schedulers, let's understand the Android. So what is Android? Android is an operating system which is built on top of Linux, and every application that you are seeing right now is nothing but a process. Every process has threads, and the responsibility of these threads is to perform tasks. And in Android we have different types of thread. We have main thread, we have IO thread, we have worker thread, and these threads have separate roles and responsibility. Main thread is actually used to update your user interface, and it will do this task in a loop. After certain period of time it will update your user interface, and that's the reason why you will see the updated UI. So main thread is actually used to update your user interface. Now let's say you want to perform network communication, and this network communication will surely take some time to process. And if you do this kind of operation on your main thread, your UI won't update. So after some time you will receive a crash, application not responding, because your main thread will be stuck. And due to this reason we'll use different thread. So main thread is used to update your user interface. Next we have IO thread, and responsibility of IO thread is to perform, let's say, backend communication, local database communication. This kind of operation you can perform with the help of IO thread. Because we are right now doing network request call, so that task must be delegated to our IO thread, and you can do this thing in RxJava by using schedulers. So this is the purpose of scheduler. You can simply switch the threads, and depending on your requirement you can switch the thread and perform your task. Let's see how we can do it. So we'll use here a repository.search, simply pass our query. Now this will actually a backend communication, a backend call. It will take some time. So I want to subscribe. So here you can see we have function subscribe on, and requirement of this thing is scheduler. So just use it and simply pass the schedulers. We have a various kind of scheduler in here. We have IO, we have single, we have from. So if you want to create any custom thread pool, you can use from. If you want to use single, you can go with single. IO is actually used to perform backend communication or local database communication, and we are only interested in backend communication, so just use IO. We have here new thread, so it will create a new thread every time, and this is not recommended because threads are very resource expensive, so do not use new thread. Then we have computation. Let's say you want to process your video, you want to process audio. This will require a huge amount of resources. So if you want to do that kind of operation, you can use computation. By the way, we are dealing with network request call, and IO will be the best choice for us. So simply use here IO. Okay, so this will call our backend, fetch the information, and once we get the information from the backend, we're gonna observe those changes on main thread. As I told you, the responsibility of main thread is to update our user interface. That's the reason why I am observing the changes on my main thread. So observe on, because it's a Android stuff, we'll use here Android schedulers main thread, and lastly simply use your subscribe, and corresponding to your response from backend you can update your UI state. So let's update our UI state, and in this we'll receive, if you can check the type that we are getting from this subscribe, mail response. Okay, so let's use here UI state update, create a new UI state instance, and in the results you can pass it. Okay, so this it is not recognizable because in this update we are also receiving it. So I'm going to call this results, and simply pass this result dot mails in it. Cool. And at the end I'm going to use dispose naming variable and create one more composite disposable, and add this dispose in our composite disposable. And when our view model cleared from the memory, I'm gonna dispose everything which is present in our composite disposable. So we get the results. Now what will happen if I receive any kind of error? On that case, if you want to handle the error case, you can simply put this thing in a small circular bracket. So first trailing lambda you'll receive the success, and next trailing lambda you are receiving the error. So just copy this stuff, come back in here, and this time we are receiving an error. So simply use here error parameter and pass the error message by using error.localizeMessage to string. And in our switch map I'm gonna use UI state update and create an instance of our UI state is loading is true. So that's it. This is all for our view model. We have repository, we have UI state, we have query which is actually used to hold the user entered query. Then we have composite disposable, and in this init we'll write few logic like first we filter it, then we produce some throttle. If user doesn't type anything for 500 millisecond, then only we'll proceed, and also we'll check if anything changes, then only we'll hit our backend API. So switch map, in the switch map we'll see the new query, and in this using this new query we're gonna fetch information from the backend. So yeah, that's it for our view model. Now it's time to begin with our user interface. So for that, open up a view, and in this main activity we shall continue, and I'm gonna use here composable naming main content, and in this main content we'll receive our UI state. We'll receive the query value, and also if our query changes we'll have a lambda for that just to update the changes. Okay, so now in this we'll use a scaffold, and in this scaffold we have top bar. In this top bar we're gonna create a text field which actually act as a search bar. We'll have to pass the value and on value change. I'm using here modifier fill max width, and also I want to manipulate its color. So by using text field default dot colors you can manipulate it. We'll use here unfocused indicator color which is transparent, and focused indicator color is also transparent. Next we have placeholder, and in this placeholder we'll have a text composable, and text says search here. Okay, this is a placeholder. That's it for our text field. Now it's time to begin with our states, like we have loading state, error state, and success state. So if our UI state is loading is true, just create a box having modifier fill max size, but before that use its inner padding. So just rename it from it to inner padding and use it in here. So in padding simply pass inner padding, and its content alignment is on the center. Now in this box we'll simply show a circular progress indicator. So this is for the loading. So if our UI state error is not empty, again I'm gonna use here box with inner padding fill max size, content alignment is on the center, and we have text in it which shows the error. Okay, so loading error. Now it's time to write our success state. So if our UI state result is not null, that means we'll receive the list of mails. So you will use here lazy column to show our list of mails. Use modifier padding, pass the inner padding, and use fill max size. Now in this we have a composable naming items, and I'm going to choose the second suggestion which has list of type T as input. Pass your data, and one by one you will receive this data in this training lambda, and we're gonna create a list item corresponding to this mail. So for that I'm gonna use here a card modifier. I want padding of 12 dp from all the sides. Fill max width. Next we're gonna use here shape, a rounded corner shape of 12 dp. Now in this card we'll have a column, and in this column first we have image, then we have the mail name, and then the description. So for that I'm using here async image. As I told you, we'll use here coil image loading library, which is actually used to load images with the help of URL. So I'm using here async image, or instead of using async image, let's use here sub compose async image, and in this we have to pass our model. So model is coming it str mail thumbnail. Next we have content description, which is null. Modifier fill max width, and its height is 300 dp. We have loading state, and in this loading state I'm gonna show a circular progress indicator. So we have circular progress indicator, wrap this thing within a box. Have modifier fill max width, and its height is 300 dp, and its content alignment is on the center. Just put this circular progress indicator within this. So this is our image. Now it's time to show the mail name. So for that I'm using here text, and in this text I'm showing the mail name, which is str mail, and its style is coming from material theme typography dot headline medium will be good. Next we'll also need to give the padding. So padding horizontally is 12 dp, and fill max width is the width. Just in between them I'm using here spacer of height 12 dp. Copy this, paste in here, and lastly I'm gonna show you the instruction, I believe. Yes, str instructions. Then we have style, which is coming from material theme typography, and this time I'm using here body medium. Modifier padding is 12 dp, fill max width, and also I'm using here a max line of 4, and my overflow state is text overflow dot ellipsis. So that's it for our list item. Now it's time to use this main content within our scaffold, which is present in our mail search app RxJava theme. So use main content, and first we have to pass modifier. Padding is inner padding. Next we have to pass our UI state. So for that create your view model using hilt view model, and type is mail view model. Now use your UI state view model UI state, collect this thing in a form of state which is attached to composable lifecycle, and pass this thing within your main content. Next we have to pass the query. So we have to hold the query values. So for that we have an state naming query. We'll use here remember savable mutable state of empty string. Now in place of query value you can simply pass the query, and lastly we have on value change. So in this on value change, first we'll update our query, And after that we'll use our view model and call this update query and pass the query. Use here variable because we want to update this query state. Import the changes, remove it, and we are done with our UI. In this scaffold, use the incoming modifier fill max size. Alright, so now open up your manifest, go to this Android manifest and make sure to take permission for internet and execute it. Alright, so I have executed the app and app crashes because of this silly mistake which is present in our main activity. We are not using hilt in this project, so how should we initialize our view model like that? It's not possible, so cut this thing out. Go in here and instead of using hilt view model, use here first just mention the type and use here a view models, import it and re-execute it by pressing Ctrl R. Okay, so now I'm gonna type here chicken. This is our loading state and there we go. This is our meals that we are receiving from the backend and it looks not delicious to me because I'm a vegetarian guy. Okay, so few problem with this image, so let's fix it. Scroll down and in your sub compose async image, use content scale in here, content scale crop and just increase the size from 300 to 320 and yeah, re-execute it. Again I'm gonna use here chicken. Now this time it looks cool. Alright, so that's it for this video. We saw how to use schedulers in RxJava and also we'll use it properly with a very cool meal search application. We're gonna build a TODO app using RxJava, and throughout this project we will learn about room database, how we can use room database with RxJava, and also we will see how we can use completable, single and maybe. So first let me show you all the dependencies. Open up your build.gradle KTS. At the top we have Kotlin annotation processor, parcelize and serialization plugin. Scroll down, we have RxJava dependency, room database dependency because we'll need database dependencies. We have navigation dependencies, serialization, view model, a lifecycle and compose material. So these are dependencies we're gonna use in this project. Now it's time to create TODO app. We'll use model view model architectural pattern to build this TODO app. So in MVVM we have three things. We have model, view model. Responsibility of model is to get data either from a remote or local data source, and once we receive data we have to write domain logic. So all of your domain logic will be present in your view model. And lastly we have view. Responsibility of view layer is to show user interface to our user. So let me create packages for them. So first we have a view, and in this view I'm gonna put my UI theming things and also my main activity. Next we have view model package, and lastly we have our model package. So first let's build our application database. So in this model I'm gonna create a package, name is local, and in this local I'm gonna create my application database. This is not a normal class, it's an abstract class, and make sure to annotate this thing with database. We have to store values in this database, so that value will be represented in a form of entities, and that's why we'll use here entities. And for the time being we don't have any entity, and in future we'll create it. Export schema is false and my database version is 1. Make sure to extend this thing with room database. We have here a companion object which will provide me an instance of our database. So we'll use here get instance. Pass your context and it will return you an instance of our application database. Return use a room database builder. Pass your context. Next, type of your database, which is app database class.java, and you can mention your application database name. So I will call it TODO database and simply build it. So now we have an instance of our application database by using getInstance companion object function. Now we are going to create entity that we want to store in this database in a form of table. So for that, create a data class, and the data class name is todo, and in this todo we have id. Type of this thing is integer and initial value is 0. Next we have title. Of course every to do has a title, and status, whether it is completed or not. Type is boolean because it represent our primary key, so we have to annotate this thing with annotation primary key. And auto generate is true because we are not going to generate id again and again. If our auto generate is true, that means database will take care about the id things. Now make sure to annotate this thing with entity annotation because to do will eventually represent an entity. Go to your application database and mention this entity to do class. Now it's time to create data access object, and data access object will act as a layer to our database, and it helps us to perform queries, to perform operation to our database very easily. So let's create data access object. This is an interface and its implementation will be returned by our room database or room library, and I'm going to call this to do data access object. Make sure to annotate this thing with data access object. We have a function upsert, so if you want to update or insert, you can use this function. Make sure to annotate this thing with upsert, and we have to check the status. So for that we'll use completable. Make sure this completable is coming from RxJava 3.core. Completable does not emit anything. It is used when you want to check whether your operation is completed or it fails. Next we have to use query. So this query is actually used to get all of the information that we have in our database. So select all from my database table, which is to do. Function get all to dos. Return type is observable because we want to observe the real-time changes, and also you can use here flowable. It's totally up to you, but I'm gonna use observable for this. List of to do. Okay, that's all. Next we have delete operation. Function delete. You can pass your to do which you want to delete, and make sure to use completable because it will tell you whether your operation is completed or not. So in our data access object we have three functions. First function is actually used to update or insert new to do. Next function is used to get all the to dos that we have in our database at real time. And lastly we have a delete function which is actually used to delete your to do from local database or room database. Now we have to return implementation of this data access object. So for that, go to your application database and just below to your companion object, create an abstract function get to do data access object and return to do data access object, and it will do the implement, and it will create implementation for this to do data access object interface and return it to you. Okay, so now it's time to create a repository. So we have a class and the class name is TODO repository, and in this class we have to access our data access object, right? So for that we require context, and in this we're gonna create a variable naming data access object and type is TODO data access object. I'm gonna use here lazy initialization. So first we'll use our application database companion object function which is get instance pass context. So now we have an instance of our application database, and if we have an instance of our application database we can simply use get to do DAO. So this will provide you data access object. Now it's time to perform upsert by using our data access object which is DAO dot upsert pass your to do. Make sure to import this to do. Okay, next we have delete, pass your to do, use your data access object dot delete and pass your to do. Lastly we have get all to dos, and the return type of this thing is observable list of to do. use your data access object dot get all to dos. So that's it for our repository, and we are pretty much done with our model layer. Now it's time to continue with our view model layer, and in this view model we have a to-do view model. It's a class that extend view model. Now in this view model we have to pass context because a requirement of repository is context. So just pass context and make sure this is accessible, private variable. So first we're gonna create a UI state for our screen, and in this we have is loading, type is boolean, initial value is false. Next we have the list, so list of to do and initial value is null. Import this to do. Lastly we have an error, initial value is empty string. So private variable UI state, a mutable state flow, and initial value is UI state. Variable UI state, use UI state and convert that thing into as state flow. Now in this we have upsert function, which is actually used to update or insert new item in our local database. So for that we'll need our repository. So let's create private val repo. Type of this thing is TODO repository, and I'm gonna use here lazy initialization. So TODO repository pass context. Okay, in this upsert we'll use our repository dot upsert pass your TODO, and I want to perform this task on IO thread because this is a database operation and surely it will take little time to complete. And if you perform this task on main thread, your application will crash because main thread is not designed to perform a task which take long time to complete. That's why I'm gonna subscribe this thing on scheduler.io, and that's it. So this will simply use to update or insert new to do in our local database. Next we have delete one. So simply pass your to do. Use your repository dot delete pass your to do and subscribe this thing on your scheduler IO. That's it. So this will do the deletion thing. So we are done with upsert and delete. Now it's time to get all of the information from our local database and update this UI state. So for that I'm gonna use our view model init block, and in this init block I'm using my repository dot get all to dos, and we have to subscribe this thing on our scheduler IO because it's a database operation. That's the reason. Now we're gonna observe this thing on our Android scheduler dot main thread, and lastly just subscribe on it. So we'll receive the list of to dos in our subscribe. Use your UI state and update its value. So UI state, and in this we have list, and in place of list you can simply pass the incoming list that we are receiving from this subscribe. This will give you a disposable. We have to dispose this thing once we are done with this subscription. So for that create a composite disposable. So composite disposable is actually used to remove all of your subscription when you are done using of it. So we have here composite disposable. Create a variable naming disposable and add this disposable in your composite disposable. And when our view model cleared from the memory, we'll use composite disposable and dispose all of the disposable that we have in it. So we are done with our view model. Now it's time to write view for our application. So open view package, and in this main activity I'm gonna write my composable. So first I'm gonna write my to-do list item. So in this we'll use row and use the incoming modifier fill max width. Just before this I want to use padding. Let me minimize this preview. So horizontally I want 12 dp and vertically I want 8 dp. Import this dp. In this row, first we have a checkbox. So in order to hold the states, I'm gonna create a variable or state naming checked. Use remember savable mutable state of, and initial value is again coming from this to do function in a form of parameter, which is to do. So this to do will have is completed. Simply use this is completed to initialize your checked state and import it. Now in this checkbox we have to pass, as you can see, checked. I'm using the checked. Next we have on check change. If user click on this checkbox, we have to update our to do which is present in our room database. So to do that, I want to use here state hosting. So at the end I'm using here on click, and when user click on it, I'm gonna pass the to do. Okay, so now in this on check change, first we have to update our item. So item dot is completed is item dot is completed not, because it's a wall we cannot change is completed. So what we can do, we can instead use our item and make a new copy of it, and now in place of is completed I'm using our item dot is completed and just revert its value. So we have our new to do item, and also we have to manipulate our checked state that we have. So for that, if you want to change the checked state, you have to use here var instead of val. Now in this checked I'm using the to do dot is completed, and at the end use on click and pass your updated to do. So that's it for the checkbox. I'm using here spacer having width of 12 dp, and next we have a very basic text, and this text is actually used to show us the item title. And we are pretty much done with our to do list item. It's a very simple list item that we have. Now it's time to write the complete user interface. So for that I'm gonna create one more composable, and that composable name is main content, and in this main content I'm gonna pass my UI state. So if our UI state is in a form of loading, I'm using a box modifier, fill max size, and its content alignment is on the center, and we simply show a circular progress indicator, this one. So if our UI state error is not blank, that means we encounter few error. Now in this case I'm using a box fill max size, content alignment is on the center, will use text, and this text is actually used to show us the error. So that's it for our error case. Now we have UI state dot list, and if it is not null, that means we are getting few list from our local database. So if list is empty, again I'm using the same composable box, content alignment is on the center, and we have a text which says nothing found. Else will use lazy column, and in this lazy column I'm using modifier dot fill max size. We have items function in it, and I'm gonna choose the items in which we have an option of list of type T. Now simply pass your list and you will receive one by one items within this trailing lambda. So use to do composable and pass modifier. So modifier I want to use here padding. So horizontally I want 12 dp and vertically I want 8 dp. Will use fill max width. So that's it for our modifier. Next we have to mention the item. So item coming in a form of it. Lastly we have on click. On click means user has click on this checkbox. Okay, Now in this case we want to update our local database to do item on which user has clicked. So for that I'm gonna just use this on click event and transfer it to my parent composable. So for that I'm using here on update click, and in this we have to pass our to do. Return type is unit of this function. So simply use on update click. So that's it for our lazy column. Now it's time to use this main content. So in this scaffold I'm using our main content. We have to pass modifier. So modifier padding, I want to use the inner padding, fill max size. Okay, and next we have to pass our UI state. So for the UI state I'm gonna create my view model first. So go to the top and use here private wall view model. Type of this view model is to do view model. I'm using here a lazy block. So to do view model and requirement of to do view model is context, so simply pass it. Okay, so now we do have instance of our view model. So UI state is coming from our view model UI state collect as state with lifecycle. Now pass your UI state in here. Okay, so now we have a composable which is capable of to show us the loading state, error state and the success state. Now how do we add a new to do item in our local database? So for that we'll use a bottom sheet. So I'm using here model bottom sheet layout, and in this we have to pass our sheet content and also we have to pass our sheet state. Now if you check the type of sheet state, it says model bottom sheet state. So let's create sheet state. So remember model bottom sheet state and make sure this model bottom sheet state is not coming from material 3. So let me check. So first one is not coming from material 3, so use it. And in this we have to pass initial value. So model bottom sheet value, and initially I want to hide it, so use here hidden. And also I want to create a coroutine scope, because you cannot use sheet state show hide function without a coroutine, because these functions show and hide is a suspendable function. That's why I want a coroutine scope. Okay, so now in this sheet state I'm gonna pass my sheet state, and in the content I'm gonna simply cut this main content and paste in here. So in our main content lastly we have on update click. So once user click on this button, I'm using view model upsert and pass the incoming to do from this function. So that's it for our main content. Now it's time to design our sheet content. So in this sheet content we have a column scope. That means components that you will write within this sheet content will align vertically because we have a column scope. So let's use here text field, and in order to store the text field value I'm going to create a new state which says value. I'm using here a remember savable mutable state of empty string. We have to pass value. So pass your value and on value change. If value get changed, I'm using the incoming value and update our value. So we have this text field. Just below to it I'm gonna use here spacer and attach 12dp height to this spacer. Below to it we have a button. So when user click on this button, I want to store this information in our room database. So for that use view model upsert, create a new to do. Make sure this to do is not the composable one, it's a data class. Now in this to do we have to pass the id, we have to pass the title. So simply pass your title, which is the value, and is completed is initially false. So once user click on this button, I want to insert a new to do, and after that I want to hide this bottom sheet. So for that you have to use scope, launch a new coroutine, sheet state hide. It will simply hide your bottom sheet. And next I want to use a user interface to this button which says add new to do, and color of this text is white. Now I'm going to attach a floating action button on my scaffold. So when user click on this, will simply open a bottom sheet, and in this bottom sheet user can enter a new to do. So for that we have a slot for floating action button. I'm gonna use the same one. So floating action button, we have on click, and in this teddy lambda you can mention your icon. So I'm gonna use here image vector icons dot default dot add, and content description is null. So when user click on this floating action button, I'm gonna use scope launch a new coroutine, and after that I'm using my set state and show it. So that's it for our floating action button. Now it's time to delete a to do. So for that, scroll down, go to the list item to do. So when user click on it, I'm using here pointer input and open a pair of parentheses, and in this we have detect type gestures, and if you click Control P, you will receive all of the parameters. So I want to use here on long press. So when user press our button for a long duration of time, on that case I want to delete it. So after this lambda on click, I'm gonna use here on delete click, and simply pass the to do which you want to delete, and output is unit. Now you can simply use here on delete click and pass your item. So go to your lazy column, and here you can simply use on delete click, and with the help of state hosting I want to host this state to my parent composable. So simply use here on delete click and use it on delete click. Now on our main content we have on delete click event. So when user click for a long duration of time on our to do, we'll use view model delete and simply pass it. So it will delete that to do item from our local database. And I think we are pretty much done with the user interface. It's a very simple user interface. Okay, now I'm going to execute this in my emulator. Alright, so our app is executing. For time being we don't have anything in our local database or root database, so let's add one. So we have an issue of padding, so let's fix it first. So for that, in your bottom sheet layout, I'm going to introduce modifier, and also I want to attach the inner padding. Next we'll use fill max size and re-execute the app. Okay, so now click on this floating action button, and I want to add here groceries. Click on this add new to do, and we have the groceries. Now I want to click on this checkbox to update the state of our to do. Now let's see whether it persists or not. So just kill the app and re-execute it. Okay, so it persists, that means updation is working properly. Now let's see whether our delete operation is working or not. So for that, just long click on this grocery, and yeah, it works. And also you can see it will provide you update of your changes which you have did on your room database instantly, because we are using here observable. You can also use flowable. If you want to use single, on that case you will not get any updation at real time, because single is used when you want to emit a single emission. So that's it for this video. In this video we have successfully created a brand new to do application, and we learned a lot of things about RxJava. We learned how we can use a room database with RxJava. We saw about completable, we saw about single, and also we'll use MVVM architectural pattern to build this application. So yeah, you will learn a lot of things. And if you like this series, please like this video. Do comment your opinion at the bottom, so that I can know there are few persons or developers who will take advantage of this playlist. We'll meet in our next video. Till that, goodbye.